You get a small cut on your finger. Within seconds, your entire body is already responding. Not one single reaction. An incredibly coordinated, multi-stage biological operation, all happening automatically. You don't consciously direct any of it. Your body just knows exactly what to do, in exactly the right order. So what's actually happening, step by step, underneath that little bandage? The real process involves 4 distinct stages, and a few genuinely surprising twists most people never learn. Let's get into it. The very first stage begins within seconds, and it has one urgent priority: stop the bleeding. Scientists call this stage hemostasis. Tiny blood cells called platelets rush to the site and begin sticking together, forming an initial plug. At the same time, a chain reaction called the clotting cascade activates, producing a protein called fibrin. Fibrin strands weave together into a mesh, reinforcing the platelet plug into a much sturdier structure. That combination eventually dries into the scab you're familiar with, a temporary protective shield over the wound. Once bleeding is under control, the second stage begins: inflammation. This is where those classic signs, redness, warmth, and swelling, actually come from. Specialized immune cells called neutrophils arrive first, often within about an hour of the injury. Their job is to destroy bacteria and clean up damaged tissue before infection can take hold. Shortly after, cells called macrophages arrive too, continuing cleanup and releasing signals for the next stage. This stage typically lasts anywhere from a few days up to about a week, depending on the wound. Next comes the proliferation stage, where your body actually starts rebuilding the damaged tissue. Cells called fibroblasts move into the wound and begin producing collagen, a key structural protein. That collagen forms a new supportive framework, often called granulation tissue, filling in the wound. At the same time, tiny new blood vessels begin growing into the area, a process called angiogenesis. Those new vessels deliver oxygen and nutrients essential for continued repair and tissue growth. This stage can last anywhere from a few days to several weeks, depending on the size of the wound. The final stage is remodeling, and it's genuinely the longest part of the entire process. The initially disorganized collagen from the proliferation stage slowly gets reorganized into a stronger pattern. This remodeling process can continue for months, and in some cases, for well over a year. Even after a scar looks fully healed on the surface, this quiet internal reorganization may still be happening. This is also a good moment to explain something almost everyone has wondered about: why wounds itch while healing? Part of the answer involves histamine, a chemical released by immune cells as part of the healing response. Histamine can stimulate nearby nerve endings, producing that familiar itching sensation. Later in healing, regenerating nerve fibers themselves can also contribute to itching as they reconnect. As frustrating as it is, itching is often a genuine sign that real, active healing is taking place. Here's why scars often look and feel noticeably different from the surrounding skin. Normal, undamaged skin has collagen arranged in a flexible, woven, basket-like pattern. Scar tissue, however, tends to have collagen fibers aligned more in one single direction. That different structure is exactly why scars often feel firmer and less flexible than the skin around them. Here's a genuinely surprising comparison. Wounds inside your mouth heal noticeably faster than wounds on your skin. Researchers have found several real reasons behind this difference. Saliva itself plays a major role, containing growth factors that actively speed up tissue repair. It also keeps the wound consistently moist, which genuinely helps cells move and repair tissue more efficiently. Oral tissue itself also naturally produces a calmer, less prolonged inflammatory response than skin does. The combined result is faster healing, and noticeably less visible scarring, compared to equivalent skin wounds. There's an even more remarkable example of this same idea, happening before birth. Research has found that early-stage fetal skin can heal wounds with no scarring and minimal inflammation at all. This remarkable ability fades as pregnancy progresses, typically shifting to normal adult-style healing by around the 7th month. Researchers are actively studying this shift, hoping it might someday help reduce scarring in adult wound treatment too. It's a genuinely fascinating reminder of just how much biological flexibility your body once had, even before birth. proper healing also depends heavily on good nutrition, especially one specific, well-documented nutrient. Vitamin C is absolutely essential for producing collagen, the key structural protein used throughout wound repair. Historically, sailors with severe vitamin C deficiency, a condition called scurvy, experienced serious wound healing failures. That historical connection helped confirm just how critical this single nutrient truly is for proper tissue repair. Quick pause before we continue. Take a guess. Do you think keeping a wound completely dry and exposed to air helps it heal faster? Actually, the opposite is often true. A slightly moist environment generally supports faster, more effective healing. That's part of why modern wound dressings are specifically designed to maintain gentle, controlled moisture. Let's clear up a few common myths before we wrap up. Myth 1: a wound needs to be kept completely dry and uncovered to heal properly. Not accurate. A gently moist, properly covered environment usually supports faster, more effective healing instead. Myth 2: once a scar looks fully healed on the surface, the healing process underneath is completely finished too. Not true. Collagen remodeling can continue quietly for months, sometimes over a year, beneath the surface. Myth 3: itching during healing always means something is wrong with the wound. Not accurate. Mild itching is often a completely normal sign of active nerve and tissue healing. Myth 4: all wounds, everywhere on the body, heal at roughly the exact same speed. Not true, as we covered. Oral wounds specifically heal notably faster than equivalent wounds on skin. Let's wrap up with a few fun extra facts. Children's wounds often heal somewhat faster than those of older adults, partly due to more active cell turnover. Some animals, like certain salamanders, can regenerate entire limbs, not just heal simple skin wounds. Studying these animals helps researchers better understand the outer limits of what biological healing might achieve. Stress and poor sleep have both been shown to measurably slow down the human wound healing process. Something as simple as good sleep genuinely supports your body's ability to repair itself effectively. Okay, let's bring this all together. Healing a simple cut involves 4 coordinated stages: hemostasis, inflammation, proliferation, and remodeling. Platelets and fibrin stop bleeding first, followed by immune cells cleaning the wound and preventing infection. New collagen and blood vessels then rebuild the tissue, before a long remodeling phase strengthens everything further. Oral wounds heal faster thanks to saliva, and early fetal skin can heal with genuinely no scarring at all. All from one small cut, quietly triggering one of the most sophisticated processes your entire body performs. If this answered a question you never knew you had, that's exactly what this channel is about. So if you enjoyed this, hit subscribe so you don't miss the next one. It genuinely helps this channel grow, and it takes about 2 seconds. Drop a comment and tell me which part surprised you the most. Was it the fetal scarless healing? The oral wound comparison? Let me know. And if you like this video, go ahead and tap that like button. It's a small click that genuinely helps this channel keep growing. There are hundreds of everyday questions just like this one waiting to be explored. Things your own body does constantly that you've never actually stopped to question. That's what this channel is all about. Toggling your curiosity on, one question at a time. One more thing before you go. Tap that notification bell too, so you actually see it when the next video drops. Next time, we're tackling why flamingos stand on one leg for hours without falling over. It's a surprisingly clever energy-saving trick, and you will not guess the mechanism. I'll see you in the next one.